Okay, so we're going to be learning a new way to plot points. The first part of the day today, it's called polar coordinates. So right here, you've probably seen 3, 4 like this. This is an ordered pair. This is the way you're used to plotting points. You may have seen this before, but we call it rectangular coordinates. Why do we call it rectangular coordinates? I don't know. We could call them square coordinates. But you notice how there's little rectangles in all the boxes. Or squares. Again, I don't know why. I really don't know why it's rectangular. But that's what they call it. Yeah, because when I copied it, it doesn't go through very well. But that's what rectangular coordinates are. Sometimes this is called a coordinate plane or a Cartesian plane or rectangular coordinates. But all of that is just how you're used to graphing things. So when you see 3, 4, you automatically do what? You start at the origin. You go right 3 because the first number is 3. You go up 4 because the second number was 4. That's how rectangular coordinates work. But that's not the only way we have to graph things. So if you look at the next page, we have what's called polar coordinates. I don't know if you guys can see those lines either. They probably didn't show up on yours. Can you see? They're circular they're not rectangular. This looks more like if you were to look at Earth straight down at the North Pole, right? And you got lines of, I don't know which one it is. Longitude, which one's which? Is longitude the...
Longitude, latitude, yeah.
Well, good. This will be like if I'm at the North Pole, these are the lines of longitude, right? As I'm looking down on it, that normally we think about being this way on a globe. Right, but that's what's going on kind of in our mind. And so you can see here's the point. This is still 3, 4 in the normal rectangular coordinates. I really wish this wasn't even here. But here's what polar coordinates looks like. The first coordinate, the first part you see, that's not your X, that's your R. What do you guys think the R stands for?
Radius.
It's the radius. It's how big the circle is. So if it has a radius of 1, this is 1. Radius of 2, 3, 4, 5, 6. This is a radius of 6. This is a radius of 6. Anywhere along this circle, that's the circle with a radius of 6. So the first number tells you what your radius is. The second number tells you your theta, which is how much we've rotated. This is 0, right? It's just like in
Unit circle.
Right, our unit circle rotations in trig. We start here at 0, pi, and so on. So let's practice plotting some points. So look at the first point. It tells me to plot the point 6, pi over 6. 6 means I'm going to go to a radius of 6. Pi over 6 means I'm going to rotate to pi over 6. Just right there.
Okay, but why is 3, 4 on the thing with 5?
I told you I wish this wasn't even there. Just ignore this completely.
Yeah.
That's the old rectangular point 3, 4. And if you want to think about it that way, I don't like that they put this. But this is where the regular point 3, 4 would go. Where we went right 3, we went up 4. Well, what would the radius be? Well, this is a 3, 4.
Yeah.
That's why it's on the line with 5. Right? But that's not the coordinate 3, 4 anymore, is my point. That's why I don't like that being on there.
Wait, where is it? It's on, like if you follow it goes.
This is the circle with a radius of 4. This is the circle with a radius of 6. So the one halfway between them with the circle with a radius of 5. Right. Next one. Can I plot the point 4, 3 pi over 4? So there's different ways you can do this. I probably like doing the angle first. So let's do that this way. If I rotate to 3 pi over 4, that puts me here in the second quadrant. So this is my rotation of 3 pi over 4. And then I need to find where the radius is 4, which would be right here. All right, that's 4, 3 pi over 4. Okay with that? Next, 2, 3 pi over 2. So if I rotate to 3 pi over 2, that puts me at the negative y-axis originally, right, which is here. And then I need the radius of 2, which is right there. Next, I've got negative 2 pi over 6. So if I rotate to pi over 6 puts me here. What do you think negative 2 as the radius is going to do?
Nothing.
It does do something. Yeah, it's going to reflect it. It's going to be here. So negative 2 pi over 6 would be right here. So basically negative 2 pi over 6 is the same thing as positive 2 7 pi over 6. Right? Those would be in the same position. So however you want to think about it, you could think if you go negative 2 and originally this is 2, so negative 2 is here, and then we would rotate pi over 6. I don't really like doing it that way, but you can, that's fine. I would rather rotate 2 pi over 6 and then move negative 2, which would move me in the opposite direction. Either way, you get the same thing.
Just to add 1 pi.
Sounds good. And then next, or last, I've got 3 comma negative 9 pi over 4. So if I rotate negative 9 pi over 4, well, 2 pi would be 8 pi over 4, right? So if I go negative 2 pi, I've went all the way around once in the opposite direction, and then another negative pi over 4 puts me here. And then I need to go to a radius of 3, which would be right there. So now we're going to be given something in polar coordinates, and we want to know what are the rectangular coordinates of that. So we have a formula for this. Does that look familiar? Sine is the y, cosine is the x. This was true for what? This was true for the unit circle. What's the radius of the unit circle? 1. The radius of a unit circle is always 1. Is the radius of this always 1? No. So we have to also include the radius. So once we find what it would have been with a radius of 1, then we multiply by what the actual radius is. And that's going to stretch it essentially, put it in the right spot. So we can find those values as such. So what is sine of negative 3 pi over 4? So negative 3 pi over 4 puts me in the third quadrant, and the third quadrant sine is negative. That's a 45-degree angle. So what is sine of 45? Radical 2 over 2. The radius is 5. So I can find my y-coordinate by multiplying 5 times negative radical 2 over 2. Right, this is my r. And sine of theta, which was negative 3 pi over 4, was negative radical 2 over 2. You okay with how I got there? If you're not sure, put it in your calculator. But we're back to unit 1. Go figure. Know your rotation on a unit circle. Next, what's the x-coordinate? The x-coordinate would be 5 times cosine of theta. Well, theta is still negative 3 pi over 4. Cosine in the fourth quadrant, in the third quadrant is negative, and it's a 45, 45, 90, so the adjacent is radical 2, the hypotenuse is 2. So the coordinates are negative 5 radical 2 over 2, comma, negative 5 radical 2 over 2. Everybody okay with that? If this is polar, convert to rectangular. So y equals r sine of theta, x equals r cosine of theta. So for us here, that would be the x is equal to r, -2, cosine of pi over 6. Pi over 6 is a 30-degree angle in the first quadrant. Cosine would be positive. Cosine of 30 is radical 3 over 2. Y equals radius is -2. Sine of pi over 6, first quadrant's positive. Sine of 30 is a half. So this means my x-coordinate is negative radical 3. My y-coordinate is -1.
How did you get those numbers inside the parentheses?
This?
Yes.
You good with this being -2, right? The part outside. Cosine of pi over 6. Pi over 6 is 30. 30 degrees in the first quadrant. This is a 30, 60, 90. Opposite the 30 is 1. Opposite the 60 is radical 3. Hypotenuse is 2. Cosine is the adjacent over the hypotenuse, which would be radical 3 over 2. It's all back to unit 1. Anything else on that? It's just another word for your normal XY plane. XY plane, coordinate plane. But see, you can't just call it coordinate anymore because polar is also a coordinate. So they're different coordinate planes. One rectangular, which is what you're used to. The other one's polar. So here I'm given Cartesian or rectangular coordinates, and I want to convert this to polar. I don't know if they give you formulas on this or not, but I'm going to.
So could we do 3 equals sine 3?
What's that look like?
A squared plus b
The
squared
distance
equals c squared.
formula.
It is the distance formula. Well, the distance formula is just... That's good. I didn't expect distance formula to come out of y'all's mouths, but it did. It is the distance formula, which is just the Pythagorean theorem solved for the hypotenuse, right? And that's all that's happening here. If you think about trying to find, let's just think about what's happening. If I go right 3, up 3, that puts me here, right? I went right 3, I went up 3. What am I looking for now? The radius, the distance from the center of that circle to that point. But what is that? That's just the hypotenuse, right?
Which is also 3.
So a squared plus b squared equals c squared. That's where this comes from, right? The radius, the c, is just the square root of however much you went on the x-axis squared, plus however much you went on the y-axis squared.
Wait, could you have a 10 and 160 triangle?
10, 10, 160? No.
How? It makes a 180.
The angles? The angles could be 10, 10, and 160. I thought you were talking about the sides.
No. We can make...
So what do we get here? This would be r equals the square root of 3 squared plus 3 squared. Y'all know what that is? 3 radical 2. You don't know that one? No, it's not. This would be the square root of 9 plus 9. What's 9 plus 9? 18. What's 18? 9 times 2. The square root of 9. 3 comes out. Radical 2. It's also 45, 45, 90, which means normally if the sides are 1, the hypotenuse is radical 2. So you multiply the leg by... Doesn't matter. You just can plug into the Pythagorean theorem, okay, and get 3 radical 2. Now how could I find theta? Theta is the inverse tangent of y over x. Where'd that come from? Well, we know tangent of any angle is y over x. And what am I solving for? I'm looking for theta. So I take an inverse tangent of both sides. Right? I mean, I don't have these formulas memorized. I'm just using my trig, right, to find them. So in my calculator, I could do the inverse tangent of y over x. Y over x, this case, is 1. So what's the inverse tangent of 1? This is 1. I don't even need my calculator for, because this is a 45, 45, 90, because the legs are the same.
Yeah.
Which means the theta has to be 45 degrees, which would be pi over 4 in radians.
Yeah, I wouldn't do my calculator on that one.
So this, yeah, no kidding. This would be 3 radical 2. Jake, you didn't know sine of 30 just a second ago. So let's don't get carried away about not needing your
I
calculator.
could figure it out
Okay.
without a calculator.
All right. So, sorry I kind of was all over the place. I showed you the formulas that you could use when you need to, but this is one I wouldn't even need formulas, right? I could do this one without, I could find the hypotenuse just by thinking. I could find the hypotenuse here without thinking. I'm not going to be easy, it's not going to be easy to find theta here, right? Theta is going to be trickier. But theta here I could find again because the legs are the same, right? So theta would be, yes, that's fine. I don't care.
So if you plug this one in, it would give you 45.
If we know
This
the
one?
formulas.
Yeah. No, the one we just worked.
Yeah, if you typed in the inverse tangent of 3 over 3, if you're in degrees, it'll give you 45. But your answer can't be in degrees. Your answer has to be in
Then
radians.
you could just
Then you
convert
could
it.
just convert it.
That's fine.
Oh.
But if you type in your inverse tangent in radians on that one, it's not going to spit it out pretty as pi over 4, right? It's going to give you points.
5.38516480.7.
Which one are you doing? This one?
No.
This one? You got 5?
It should be 45.
No. I'm doing the second one.
Oh, this one is ugly. Yeah, this one, and I can't turn that one pretty. Like, I don't know what to do on that one.
Yeah, it gave me 5 point something Imaginary.
I?
Imagine if
Oh.
It's not going to have an I.
It's because you're probably in A plus B almo. Yeah, you are.
Man, A plus B, I don't know. What does that mean?
I have no idea.
It's a sussing mode. Just put it in real mode.
It's complex numbers on the complex plane. We're fixing to get to that, but not yet. So, on the next one, could we find the radius?
Never mind. It gave us an error.
R equals -2 squared plus -5 squared. That would be radical 29. You didn't put your negatives in parentheses if you tried that.
No.
So it's going to give you an error.
Yeah, it gave me an error.
Yeah.
How'd you get that so fast?
Me?
Yeah.
25 plus 4. I'm not some whiz. I mean, maybe I am a whiz kid, but I don't think that would took a whiz kid. I know 5 squared. You know 5 squared?
Yeah.
25.
I know 2 squared. You know 2 squared? I can know how to add those. I mean, that really wasn't groundbreaking. I don't feel. Maybe. I don't know. I mean, some stuff I do is impressive. That was not one of them. I don't feel. Next, I'm looking for theta.
Okay.
So you gotta use the
So I would do the inverse tangent of y over x. And I would just go ahead and put this one in radians because it's not going to be pretty either way. Inverse tangent of -5 over -2.
Do we have to do anything in parentheses?
-5 over -2. There's nothing being squared, so no, it doesn't matter.
Isn't that just?
What'd you get?
Is it negative 0.7?
No.
1.1902895.
Okay, explain it.
Are you in radians or degrees?
I did regular tangent, so.
You take tangent of angles to get side lengths, ratio of sides. We're looking for the angle, so you have to take an inverse tangent.
So
This is not the answer. Notice I didn't write it in there.
A box.
0.38.
Why is this not the answer?
Because that is not a radian.
Wait,
It is in radians.
no. I didn't get that again.
I'm not even sure.
Are you in radians?
I'm in radian.
Inverse tangent of
Inverse
-5
tangent.
over -2.
Oh, it's
Oh my gosh.
I'm a bad.
Y over x. Tangent's y over x.
Is it not?
Why is it not 1.19? Oh,
Because
what did we just do? We just took
Put that
in.
on the.
We just took an inverse tangent.
Oh, you gotta multiply.
you have to divide by.
What? Maybe? I'm just hoping somebody figures this out without me.
You have to do that law of sine.
It's on. Wait, I think I probably have it out
This is hard.
somewhere.
I took an inverse tangent. Where does inverse tangent exist? Quadrants 1 and 4. What quadrant is this in? Well, this is supposed to be in quadrant. I went left and down.
3.
Supposed to be in quadrant 3, but I know the ratio is positive, so it spit me out something in quadrant 1. But I need to move this angle to quadrant 3, which would mean I need to add pi
How
to
is
this.
How is that in quadrant 3?
This is not.
Why is it not?
So we add pi to our answer every time.
No. Depends on what quadrant it's in. The same thing we had to do back with the inverse tangent
1 radian.
stuff. You have to make sure that you're doing it for quadrant it's defined for. We didn't have to do it here because what quadrant was I in? 1. Well, inverse tangent was defined for 1. What quadrant is this in? Right 3
You
down.
said that we only add
4.
pi sometimes.
Inverse tangent's defined for quadrant 4. So we'll be good there as well. Won't even have to worry about moving it. Only time you have to move it is when I'm in quadrant 2 or 3.
Oh.
What do we get? 4 point.
0.332. Wait, what did y'all do?
Can I skip the last one? Oh, sorry, go ahead. Go ahead,
Oh,
Jay.
you do this, add pi.
That's all I did this time.
Because you're.
Because this was in quadrant 1, I needed in quadrant 3. So to get this reference angle in quadrant 3, add pi to what's. I could draw it out, but I feel like I've done that several times. If it's in quadrant 2, you would do pi minus.
Okay.
Well, actually, no, don't do that. If it's in quadrant 2, it's going to spit you an answer in quadrant 4, which means I can still just add pi. So just add pi. Let's just go with that. If it's in quadrant 2 or 3, just add pi. Hey, add pi.
But what if it's in what? Wait.
If it's in quadrant 2 or 3, add pi. I'm going to go look and see if they do it. I still don't feel great about what we've done.
So 3 pi over 2, we know that. It's good.
That is the radius. The radius is going to be 3 radical 2.
Yeah.
Oh, sorry, you were giving me the angle measure.
No, that's what I meant to say, 3 radical 2, because it's the same. Just negative.
So- If you don't know theta, you could do theta equals inverse tangent of -3 over 3.
Wait, did I just walk in? I think I just walked in.
What'd you get?
I found Y. 7 pi over 4.
7 power 4, or I did negative power 4. Same thing.
Wait.
Because if I type in inverse tangent,
It's
you'll
just
get
ne-
negative
it's-
power 4.
It's the same one we did at the first one, it's just negative. Cause,
Yes.
so I just went negative.
Sounds good.
Wait.
When I have r and theta in my answer, not x and y. If you guys look at that Cartesian equation, do you know what that is? This is something that you've done before, probably in Algebra 2. You've graphed this. But we don't spend a lot of time graphing this because it's not a function. Right? And so everything we work on are functions. This is not a function. Does anybody know what this would graph? No.
Circle.
It is a circle. Do y'all remember the equation for a graph of a circle?
X squared.
Plus y squared equals c.
Oh, that's what you're working on right now.
X minus.
In Algebra 2? Yeah. That's where you learn it.
Really learned it last time.
All right, so this is the equation of a circle. H and K. Think about what this does. What does this do with our transformations of graphs?
H of k.
What's the minus H? This is going to shift the graph left or right. It's going to be opposite from what it says. That's why it's negative. Well, this is kind of new, right? Because we don't normally have something with a y, because the y is normally isolated. But this is just going to shift the graph up or down, and it's going to do the opposite of what it says. That's why it's minus. And so this, give me 1 second. It's going to be centered at h comma k. That's where the circle is centered. So whatever is the opposite sign of this number, opposite sign of this number is the center of my circle. And then what's the r represent? R is my radius of the circle. Do you have a question? I can answer that.
It's kind of off topic, but it is about this
Then let's-
class.
let's-
It's about this class.
Well, Jack had something about this class too, but let's don't go down there right now. So where's this circle centered? What's its H and its K? 0, 0. This is centered at the origin. What's the radius of my circle? 3. The radius is 3 because this is the r squared. That's the square root of that. So I need to find the equation of a circle centered at the origin with a radius of 3. All right, are you ready?
I got you this.
Y'all remember this?
Yes.
We don't want x and y anymore. We want r and theta. Well, guess what this is in terms of now? R and theta. So I just plug in. So this gives me r cosine theta squared plus r sine theta squared equals 9.
Do we put the 3 where it was?
We don't.
Not yet.
We don't ever. On this. So r squared cosine squared plus r squared sine squared equals 9. But care that when I squared it, I got to square everything inside the parentheses. So square the r, square the trig function.
What about theta?
No, theta is what I'm taking the sine of. So I just square that term. I square sine. I square r. Theta is not its own entity.
It's a sidekick of science.
I always used to say it's sine and cosine are holding theta hostage. It's stuck in there. The only way to get it out is take an inverse. All right. Now, if I factor this, I've got r squareds in both terms, so I have a GCF of r squared. So factor r squared out. If I factor r squared out, that's going to leave me with just cosine squared plus sine squared. That looks oddly familiar. 1. R squared equals 9.
What? What? Is there any way to do that?
Welcome to trig class.
Is there any way to do this without knowing that common knowledge? I don't know that common knowledge.
I don't know what you're talking about.
I don't know that cosine squared theta plus sine squared.
We learned it. We just learned it. In our Pythagorean identities. All about our proven identities. Of course Jack didn't know it. Jack didn't know sine of 30 was 1/2. What are you talking about?
Oh, so r equals 3.
Plus or minus 3, because you took the square root of it.
Thank you. But I don't care. That's the same thing in this.
Didn't we already know that? Did we not already know that r was 3? Because she said r was 3.
She did say r was 3. Y'all should know what the equation looked like. Now that's the equation of circles in polar. It's just r equals whatever the... So like, I go everywhere. Basically, if you think about it, go everywhere that r is 3. Well, where's r 3? Well, it's everywhere on that circle with a radius of 3. That's where r is 3. That's what I wanted, was a circle centered there. So that's the equation.
So, not just take the square root of the 9 and then...
When it's centered at the origin, yes. It's that simple.
So we
But it's not always going to be centered at the origin.
It says it equals 9, and she said that r was 3. So can we do that? We can do that?
Because that's 6y.
So we have to do this skew problem.
Yeah.
Figure out where it's centered.
Yeah, I need to figure out where it's centered. Does this look like a normal radius to us?
No.
No. So, I'm going to show you... Don't write this down. I wouldn't write this down. This is what you would have to do if you didn't know polar. If I wanted to know where this circle was centered, you should have done this in Algebra 2. I move the 6y over, it becomes negative. And now I have to complete the square. So you take your b term, you half it, -3, you square it, 9, which means I need to add 9 to both sides. Which means I know what this factors to be. This would factor to be y minus 3 squared. That's y minus 3. This is called completing the square. We've done it earlier this year. We took our b term, we halved it, we squared it, we added to both sides. I showed you that when I showed you where the quadratic formula comes from. I showed you how to complete the square, then I showed you the quadratic formula. Doesn't really matter. My point is, this is the equation in Cartesian coordinates or rectangular coordinates. This is a circle centered at 0, 3 with a radius of 3. Okay? This is what it should look like in rectangular coordinates. But we don't want it in rectangular coordinates. We want it in polar coordinates. So you don't even have to do this. Like, you don't need to know these steps anymore. This is the Algebra 2 stuff that you should have known. So now, that's not what we're doing. What y'all not? I told you don't write that down. That's not the answer. That's not how this is going to go. Nobody's listening. This day is awful. I don't know what y'all have done. I feel like I've lost my 113 class. Like, I don't even know who y'all are anymore.
I think you lost in the trash.
Is it because I've got to plug my... Anyway, I don't care.
Jack, you are lying.
R cosine theta squared plus R sine theta squared equals 6R sine theta. But you see what I did there? X equals R cosine theta. Y equals R sine theta. Guess what I'm going to do over here?
Cancel saying theta out.
This is just r squared. Is it okay with that? It's the same steps I just did. Factor an r squared out. I'm left with cosine squared plus sine squared, which is 1. R squared times 1 equals 6r sine theta. I'm drawing a circle. What is r? It is the radius. What else can we say about r? If you're drawing a circle, what is something that you know r is not?
It's got the whole length of the circle. It's not.
Never mind. I'll just answer it. If I'm drawing a circle, the radius can't be 0. If the radius of the circle is 0, it ain't a circle. It's nothing. So, because I'm guaranteed the r is not 0, I can divide by r.
Yay.
This tells me r equals 6 sine theta.
6 sine theta.
Okay, so I have one tiny question. How did we just get rid of cosine theta squared plus sine
Because
squared?
it equals 1.
Because it's the common knowledge.
The common knowledge.
That you didn't know.
Yeah, you want me to show that again?
Alright, I know it now.
You good with that now?
Common knowledge that it equals 1.
Yeah.
Cosine theta squared plus sine squared is theta squared.
That's 3a.
Oh, no.
All a circle centered at centered at 3, at 0, 3. This is what that looks like. Let's prove it real quick. Everybody get your calculator? I'm sure you all do. Let's click mode. You see on the 5th line where it says function, switch it to polar. It should be in radians. Thank you. Yeah, also in radians.
So radian.
Now we click y equals.
R equals.
Ooh. So if I typed in r equals 6 sine theta, but guess where theta's at?
Where's theta?
X.
to theta.
X comma t comma theta comma n. It depends on what mode you're in. We're in polar, so it's no longer x. It's now.
Wait, what did you say? You say 6
So if I click zoom 6,
Whoa.
Wait, r 6 sine of theta?
does that look like the circle centered at 0 comma 3 with a radius of 3?
So then we click graph.
Yeah.
Oh, but mine's really
It
small.
does look more like an oval.
It does. It's because of the pixels. If I go to, let's go to zoom. Where's zoom fit? Is it 0? If I click zoom 0, it should look more circular.
Like this? It should look more like a
Right.
Well, how did y'all do that? How did you make it large?
Zoom fit, zoom 0.
Larger than
Zoom 0.
I was a circology for this Sasquatch problem because I tried looking it up on TikTok and it's just this weird guy like talking about big.
How to get rid of Sasquatch? Yeah, no. Let's look at this one. Rewrite this Cartesian equation. What does this look like in Cartesian? It's a line. It should be a line. So what would this line look like in polar? Well, let's solve very quick. Y is r sine theta equals 3 times r cosine theta plus 2.
Cam, this is Colin. Common knowledge. You should know this.
Now I need to get r by itself, so let's get r's on the same side. So this becomes r sine theta minus 3r cosine theta equals 2. Factor an r out. Divide by the garbage. Because again, I'm trying to get r by itself.
Oh, that's so cool.
And so here I should get r equals 2 over sine theta minus 3 cosine theta.
Yeah, but now you can put this in your calc.
See if it looks like a line if you type that in. 2 over sine theta minus 3 cosine theta. They're like a line with a slope of 3 and a y-intercept of 2.
It does. Indeed.
All right, here's the next one. What are we supposed to do? I don't really know, just to be honest with you. I'm really that freaking out right now. But anyways, don't tell me, Brandon. I'm gonna figure this out on my own. I'm gonna be a grown man. I'm gonna take my medicine here. Not know what I'm doing. So I've got this is polar, okay? We all know polar. Hello, polar. We don't want you in polar anymore. We want you in rectangular. So I don't want r and theta. So I need them to go away. So the only thing I can think of right now, which again, I don't know if this is going to work. I know x squared plus y squared equals r squared from the Pythagorean theorem. We've been using that very I could divide by or not divide. I could take square roots. That's probably not good. Am I wrong? Me too. I told you I don't know what I'm doing. Don't copy this.
Why not?
Because I don't know what I'm doing. I'm just winging this. I'm not lying. I have no idea what I'm supposed to be doing. I'm not taught this. This is not a lie. I don't know what I'm doing. That sounds good. Let's move the secant over.
I guess I thought you might try to get r sines of theta because you know that would be y and then
Subtract the 2 secant.
you
Why is it?
So to do that you have to.
Because we subtract the 2 secant
Mm.
from the right.
Yeah.
He said no, and he said yeah.
Let's try it. I like it. I like where your head's at. R equals 2 secant of theta, but I hate secant. So R equals 2 over cosine theta. Because if I move secant to the denominator, I like that. That's something. Thanks. I was so lost. I see a fraction equal something. You know me. Make that a fraction equal to a fraction. I'm going to cross multiply. This is what you guys wanted, wasn't it? R cosine theta equals 2. Oh, thank you. So R cosine theta is, sounds good. There it is. X equals 2. That's a rectangular equation. Can we graph that? Do you know how to graph x equals 2? We go to 2 and we say, hey, draw a vertical line. All right, all this you just ignore. And this you ignore. Here's the good part. Thanks, Brea. Hi, welcome. So Brea taught us so much, I now know what I'm doing. I still don't know what I'm doing, but the video thinks I do because I deleted everything. So this is R equals 3 over 1 minus 2 cosine theta. I'm going to put that over 1 and cross multiply because that's who I am. I'm Mr. Consistency. r minus 2r cosine theta equals 3. All right? We know r cosine theta is x. And we know r equals the square root of x squared plus y squared. Because we know x squared plus y squared equals r squared for my circle. Just square root both sides. So I'm going to plug in, instead of r, I'm going to say the square root of x squared plus y squared minus 2 times x equals 3. I want to get that radical gone. I don't want that. So I'm going to isolate the radical, which gives me the square root of x squared plus y squared equals 3 plus 2x. Radical is isolated. So how can I get rid of square rooting something? I square it. Both sides. Squared square root, gone. X squared plus y squared. If I square 3 plus 2x, remember what that means. That's 3 plus 2x times 3 plus 2x. So this becomes 9 plus 6x plus 6x, which is plus 12x plus 4x squared. Question?
No, that's just where it got different. Because I had y equals square root of 9 plus x squared, which might be wrong, but whenever I squared it, I didn't make the radical.
You squared this. That's all you squared. Right?
Well, okay, before you made the radical by itself.
Yep.
I squared that whole thing.
Squared this.
Softball game that was scheduled for this afternoon has been canceled. It has been
You have to square this whole side.
next Tuesday
You'd have to distribute.
Okay.
I don't know.
Tomorrow, we will be on regular schedule, okay? Tomorrow, we will be on regular schedule. Also, if the toilet in the 5th and 6th grade hallway in the boys' bathroom gets stopped up again by some kind of objects that do not belong in the commode, it will be closed permanently, okay? So guys, quit putting
What are we
stuff in the
talking
commode,
about? You
alright?
can't close a
Thank you.
bathroom permanently. That's the most empty threat I've ever heard.
We'll
We'll close every boy's bathroom. Then we won't have school.
I mean, I'm done.
They need a more serious, not close the bathroom. That's not a threat. You need a real threat.
Everybody, every week.
So from here, if I were to distribute this, now I've got to do square root of x squared plus y squared times the square root of x squared plus y squared. The radicals cancel. That's going to be x squared plus y squared. You had that. And then if you multiply the last one, negative 2 times negative 2 is 4. But you didn't do the outside inside. This is going to be negative 2 radical x squared plus y squared minus 2 times square root of x squared plus y squared plus that 4. You didn't make it prettier. You could then combine these.
Yeah, I guess I just left it minus 2x squared.
You just squared this on its own. You squared part of the left side
Yeah,
and this side.
and minus 2x, because I said minus 2x squared.
You can't square each individual term. You have to square whole sides. You have to do it to both sides, not to each term. We never do anything to each term. We do it to the entire side. The thing that people get messed up is because whenever you do the addition, you feel like you only pick a term to add or subtract, but that's just because we pick a like term to combine it. But you really are just adding 3 once to both sides. This is not what you're talking about, but I'm going to rant now, if that's okay.
Ain't nothing wrong with that.
As of right now, I'm not happy. It's me, Cole, Aaron.
Like, well, something I can do here, why would you do this? You wouldn't. We could add 4 to both sides. or we can. But we don't add 4 here, and 4 here, and 4 here, and 4 here, and 4 here. Because now then you've unbalanced it. Now you've added 8 on the left and 12 on the right. We just do it once on each side. And we just strategically pick the one that's a like term to stack it with. Because that's what I can combine. Does that help answer?
Yes, actually.
That's one of my big misconceptions I see all the time that I never get a chance to talk about. And now I just did. And will you? So now then you'll never make that mistake again, right?
Really hope not.
Nothing. You should have been listening. So from here, I got x squares and y squareds. We've been graphing circles, which means I want to turn this into an equation of a circle. Do you remember what that form looked like? It was x minus h squared plus y minus k squared equals r squared. So I'm going to take this and I'm going to make it look like that. Okay? You follow what I'm saying? So I need to let's get everything that's not a number on the left side. So this is going over. This is going over. Huh? Leave 9 by itself. Exactly. So I've got, can I change my mind?
You can, sure. Haven't read anything down yet.
No, let's just do it. That's going to be, oh my gosh, negative 3x squared minus 12x minus y squared equals 9. Plus y squared. Oh gosh. Have I messed something up? Brandon, have I messed something up?
What?
Have I messed something? You're not paying attention. Never mind. Why? No, it's negative. I hate that. Man, I hate that. Okay, so, yeah, it's going to make this next part ugly. I was hoping it'd be an easier first one to do this with. So, that's why I looked at what they were just to make sure. So, you're lost. You say you're lost?
Yeah,
I'm lost, but lost.
I'm trying to take this and make it look like the equation of a circle. Because that's what it is. It's a circle because it has x squareds and y squareds. It's an ellipse. It's circular. How about that? Can I say that? It's not going to be an exact. No, absolutely not.
Trying to get it into the other thing.
Yeah, it was a circle.
I was trying to get y by itself originally, but that's not what they want us to do. They want us to put it in like equation of a circle ellipse form.
So I thought we were trying to get it into Cartesian.
We are. Cartesian means it just has x's and y's.
Okay.
And this does have x's and y's. So this is technically a Cartesian equation, but it is not in any. Do you know how to graph that?
Good.
Exactly. I mean, I got no idea how to graph that besides just type it in the way it is. So I need to get this in a form that I recognize so I can get some characteristics of the graph. Okay, so this is awful. This is going to be awful. These here are 2 x's, 1 squared, 1's not. Thank you for that. I need to write that as a single x. So let's just think about this. What is this really? X minus h squared means I really want x minus h times x minus h. That's what x minus h squared is. Which means I need to turn this into something that I can factor and get the same parentheses twice.
Complete the square.
So complete the square. I need to complete the square of this.
That's boring.
Thanks, Brandon. So what I want to do then is I want to get rid of that -3. That's why I was looking like, please tell me that's not supposed to be there. But it is. So I've got to get rid of that by factoring a -3. Can I just write this on a new page? This is fixing to get ugly. Born in radians.
It looks like someone took a line and cut it in half.
Wait, we are in radians?
Give me 1 second. It should be in radians. Absolutely. It should be in radians.
Yeah, it's reducing the
R equals a fraction. 3/1 minus 2 cosine.
Oh my god.
Theta.
Holy crap. That's supposed to be right?
No, you're probably in like parametric or something.
I'm in
Zoom.
Poland. Radiant Poland.
That's like a hyperbolic graph.
Hey, I ain't got nothing on my graph.
What's this on my graph?
Hyperbolic graph.
Does it look like a
That's
star?
what mine looks like.
Your graph blank, cause on it.
Is your Zoom right?
Also, let's see it.
Zoom 6? I got a blank graph.
You got a blank graph.
I got it.
I think I
Surf
got
into
that.
Star
Do
Wars
it.
graph.
Mine is Zoom 6, mine has something.
That's what I got.
Did you
Mine
notice
does.
mine?
Yes.
Mine does. It's just like a weird.
It's
It's like a.
Mine keeps
Hold on.
going.
Go to mode and then click.
Mine keeps freezing. I picked a bad calculator to do this.
Yeah. But you have to change it to R.
It's what?
It's a star.
A star?
That's like a Pokemon jar. It's a weird thing.
I had to go for
You get a polar.
Yeah. That's so long.
Dawson, I don't know why yours looks like that. Mine doesn't.
Well, you also have software on yours that does everything.
Let me see yours, Brandon.
Does it supposed to look like this one or this one?
That's the way mine looked when I did it.
Wait, is that what yours?
But my calculator
This is what mine looks like.
Probably.
Looks like a
Mine
star
looks
as
like- I got a
well.
little star.
Oh, everybody got
Yours
a
is
star.
if you zoom
I don't know what
in.
those
You
dots
had a
are.
weird
Yours
link.
are-
Why? Mine might look similar, but it's
You just froze it. That's what mine kept doing. You see the spinning circle?
Yeah.
It didn't finish drawing.
Wait, is that
Stop
right?
pushing it. It is right. Mine was just being goofy.
So it is right.
Mine was zoomed out a lot.
Everybody's I'm looking at has got it. Okay?
That is so cool.
So what's
I want to zoom in. It's just so cool.
-3x squared minus 12x plus y squared equaled 9.
Yeah.
Thanks.
I've been learning this.
Now I'm going to GCF a -3 here. That's going to leave me with x squared plus 4x plus fill in the blank plus y squared equals 9. So I factored a -3 out of here. I left a blank because I'm fixing to factor this again. So I'm going to choose to add something to both sides. I'm going to be strategic in what I choose though, because I want it to be something that will be the same parenthesis twice. Right? That's the whole point of factoring. So what should go here to make that work? We want the A term to be 1. Check. Take our B term. Half it. 2. Square it. 4. We want to add 4 right here. That's the number we want. So, I want this to be a 4. Well, I just created that out of thin air. So I put a 4 on the left side. So if I have put a +4 on the left side, that means I should put what on the right side?
No.
A -12.
what?
Oh, I forgot about that.
Because this -3 was on the outside of that. So if I distribute this to get a -12 is really what I've done on the left. I need to also subtract 12 from the right. This is going great. That got me too. I knew it was coming. Thanks, Brandon. So if this is -3, this factors to be x plus 2 squared plus y squared equals -3. Is this for real? Is this real life? That can't be real life. What do you mean the radius is -3? It's going to go the opposite direction. You know what? My brain's hurt. Let me double check again to make sure I didn't do something wrong. But then I just saw that this is where he was going.
Are we allowed to have a cheat sheet on this one?
1.2.
Are we allowed to cheat on this one?
Don't get caught.
The cheat sheet
I don't even need the sheet, I just need the cheat.
Just plug photo map.
This stuff is
It's
very
absurd
strange.
at this point.
It is very strange.
Well, I understood it.
Oh!
Yeah, me too. Like, it was good.
Oh.
Just like pre-cal or pre-swim
Now, we're going to divide both sides by -3.
Of course we are.
Yeah. Because
After that,
who really wants this anyways? It's gone. That's going to leave me with x plus 2 squared. But I can't just cross out like this. This is really, that was bad practice on me. Just pretend like I didn't do that.
Oh, no.
Because I have to divide everything by -3. So I divided the first term by -3. I have to also divide the second term by -3. So y squared over -3 is negative y squared over 3. Equals 1. That's it. That's the formula I wanted.
No way. So we went from r equals 3 over 1 minus 2 cosine theta to literally everything.
Yeah. So
stupid.
here's what I want us to do.
Is there an easier way to do that?
You guys have your calculators?
No way. I could have just done this in our calculator.
No. Let's type in our original equation in polar. Everybody remember how to go to polar?
Poland?
Wait, it's degrees.
What?
So let me just show you this because you guys had a great idea that I think I'm going to go with. We want to go to Desmos. Desmos. So we get x plus 2 squared minus y squared over 3 equals 1. So that is the same thing you have.
It's like half.
Yes, yours has that. Yours has that. The other stuff is
Those asymptotes.
like asymptotes that show up when sometimes you graph rational functions and it's so pixelated on there that it can't skip. This is what it really should look like. If I were to go, let me graph in polar. Do you know how to change to polar on here?
Probably settings.
You can change it.
Your settings. Where's that at? Over here?
I think it would be the gear.
Oh,
You said a gear?
Right there.
No,
Right there.
there you go.
No, probably the wrench on the far right.
Y'all just gonna keep making up junk down there quick? More options. Complex mode.
Probably. Try to
Big
do
brow
red.
mode?
Here, what's our R equals? I'm just gonna try to type it in. R equals
3 over.
3 over 1
Minus 2 cosine.
How do you spell theta?
It's got a. Yeah.
No, like on the.
I just had to type in R and it just automatically went to public. That's what I thought it might.
There.
It used that.
So this is what yours looks like, but it's just, yours has got the pixelated asymptote. Rewrite r equals 2 sine theta in Cartesian form.
It's gotta be.
I heard you say that once, and I was like, no, we're not. We're not doing decimals anymore. We've moved on. Well, my old trusty trick of putting this over 1 and cross multiplying ain't going to do me a whole lot of good this time. Because it's still what it's... Okay, so that's out.
This one should be easier to do.
Easier, yeah. I agree, Brandon. This one's so much easier.
It's not easy.
Because this is so easy. Right? This one's so easy. Here's what I'm thinking.
So did they design this for
I would divide by 2.
Sounds like a bad idea.
Go ahead, Brandon. What should we do here, Brandon?
You want the r to be r squared, so
Square both sides.
that's my hint. The r needs to be squared somehow.
Square both sides. I can do that.
Brandon's giving the teacher hints.
R squared equals 4 sine squared theta. Hey, I know what r squared is. I should tell him not to copy this.
Oh, really?
Yeah.
Is that wrong?
Oh,
Figure it out.
yeah.
No way.
Oh my god.
I'm just not gonna write anything.
Let's multiply both sides by r.
Oh, you got it.
Oh my goodness, it makes so much more sense.
That,
Makes
no
no
kidding.
sense at
That
all.
makes that r squared,
Oh,
and this becomes 2r sine theta.
that's great.
It's a lot better idea. X squared plus y squared equals 2y?
And I think you just leave it like that.
No. We're going to move this over. X squared plus y squared minus 2y equals 0. Now I need to get this into circle form. So I need to complete the square. Oh yeah, this is going to be great. So I've got x squared. It's fine. Y'all know why I'm only doing it with this one? Because it's got the extra junk. But if it doesn't, then it's fine. Just leave it. So this becomes y squared minus 2y plus something. So what needs to go in my blank to complete the square? Well, make A term 1. It is. Take my B term, half it, -1. Square it, 1. Which means I need to add 1 here. Well, if I add 1 here, what gets...
No, you don't. Just do that.
It is 1 this time. It is 1 because there's nothing funny in front of it. Okay? You add 1 over here. So this is x squared plus y minus 1 squared equals 1. There we go. I know what that looks like graphically. A circle centered at 0, 1 with a radius of 1.
Are we gonna worry about these weird looking flowers?
We are.
Today?
No, you don't have one.
Okay, so we'll talk about these a little bit. The part that you have to know for 113 for this, you guys, a lot of you told me you already did it, right? They do not, it is not very difficult. But you got to know a little bit more for pre-cal than you do for 113. So let's talk about these for a minute, Let's see how much of this I can remember, because it may not be great. So, to get circles, we just have r equals a number times sine of theta. A is just some number. Both of these give a circle. But they give circles in different places. So do you guys have your calculator? So I want you to type in 3 sine of theta. Y equals 3 sine of theta in, make sure you're in polar. And tell me what that graph looks like.
It looks like half a circle, or like 3/4 of a circle.
It should be
Looks
a,
like a circle.
it should be a circle.
It should be a circle.
Where is the circle?
It touches the origin, but it goes up to 3.
R equals 3 sine of theta.
It's centered
Centered
at
at-
1.5.
0, 3.
Right.
0, 3.
It has a diameter,
At 0, 3.
a diameter of 3, right? And it's on the y-axis. So now type in 4 sine theta. See what that's going to do.
It's going to be centered at 2.
It's going to have a diameter of 4 on the y-axis still. So my sine polar graphs are on the y-axis. Now do cosine. Type in 3 cosine theta.
How did you get that?
Where's that go?
To the right.
On the x-axis. So this is really a cosine graph when I look at this, right? 3 cosine theta would be a radius of 1.5 here. 4 cosine theta, 5. So cosine's on the x-axis, sine's on the y-axis. Oh, okay.
This one's centered at
Now,
1.5.
what's different between this form and this form?
Plus or minus.
This has plus or minus. There's some constant that's being added or subtracted, right? It's still a number times sine and a number times cosine. But the difference is something's being added or subtracted to it. And notice, that's the same with all of these. Something's being added or subtracted. You see that? So whenever you start introducing a constant being added or subtracted, if they both are positive and a divided by b is 1, how could you get a divided by b to be 1?
They're the same number.
They're the same thing. So if they're both positive and a and b are the same thing, you get a cardioid, which is like a heart shape. That's why it's cardioid. Cardiovascular. Cardiac arrest. That's why that's called a cardioid. Because it's heart shaped. So, when A and B are the same, you get a cardioid. Let's look at this one. Here, if A if A is less than B, so if they're both positive, and A is less than B, that means B could be 5, A could be 4, 3, 2, 1. You're going to get an inner loop. I don't know how to say that word. I never can remember. Limison. Limison. I think is how you say it. Limison.
Is there a little thing here to see?
Yes, it's one of those
Weird words.
French C's. Or whatever. Limison. Oui. I don't know what I'm
Ask
talking
Google
about.
Translate.
So, in your graphing calculator, let's make up an equation. Let's make A and B positive, but let's let A be less than B. So let's try 2 plus 3 cosine.
2, still need cosine.
Remember, where was cosine? Normally, cosine's on the x. So if I type in 2 plus 3 cosine, it's still on the x. What's the diameter? What's the diameter of the circle? 2 plus 3 cosine. Can you guys tell the diameter?
Just start from there, 5.
Yeah, because it's 1 over.
1, 2, 3, 4.
3 plus 2 equals 5.
That's it. Did y'all see 2 plus 3 cosine gives a diameter of 5? Where did the 5 come from? 2 plus 3. What about the little loop? What was its diameter? 1. Where does that come from? 3 minus 2 is 1.
It's more than 5 though.
The diameter is not.
No, we just counted.
Wait, how tall it is?
No.
0, 1, 2, 3.
From here
No, don't start.
to there.
Yeah, it's a little.
Okay,
Start
so
from 0.
1, 2, 3, 4, 5.
Start from
Yeah, but
0.
it's
So count 0 as 1.
What
Okay,
is?
so start.
I'm not talking about this one. It's not a perfect circle.
1.
I'm just talking about from the center to here. I get what you're saying. It's this way a little bit more. Yeah. Just ignore that. We just go out to 5 here. Diameter may be the wrong word. It's not a circle. That's just, again, this is not some of my favorite stuff. I'm new to this math.
Look at this.
Type in, let's make up some more numbers and see if we can figure out what it's going to do.
9.
Let's guess it. Let's don't go that big because it's going to go off our graph.
4.
3 plus 4.
3 plus, how about 3 plus 5? And let's switch it to sine. What do you think that's going to do if I switch to sine?
It's going to go to the Y.
Should go on the y-axis. How tall do we think it's going to get if we go 3 to 8? And how big is the inner loop going to be? 2. Because of 5 minus 3. See if all that's true.
-0.5.
Do you follow that? Could you answer a question? That's about as difficult as the questions get on the AP exam.
Inner loop limit.
For these.
What about the Archimedes spiral?
You should do less than 0. Less than.
It gave me. It was almost.
Okay. Now let's
It
just.
had like all the circles inside of
Yeah,
it.
just said the one. I think it was Archimedes spiral. Yeah.
Now, what happens if
That's what
A is bigger than B, but it's not more than double it? So let's switch. Let's do 3 plus 2 cosine. You see how I flipped it? 3 plus 2 cosine. So cosine goes on the x-axis. So if I type in 3 plus 2 cosine, what's different? There's no more loop, right? It looks more like a cardioid again. It's not exactly a cardioid. It's still called a limicon, but it's not an inner loop limicon. Okay.
What did we just do? 3 plus 2 cosine?
3 plus 2 cosine.
No theta.
Yeah, there's still the thing. 3 plus 2 cosine theta.
3.
Sorry. You know I leave that part off all the time.
The Indians used to put it on the feather.
So we're still doing.
So how far? Let's see if we can figure out how the stuff happens there.
It knows there.
How far does it go over from the y-axis?
It goes over from the y-axis.
How much? Count over. How far over? 5 from the y-axis. Right? The difference is it's got one more to the left. Where does that 1 come from?
The thing being.
The 3 minus 2. Just like the inner loop, whenever it was flipped, that was how far to the right we kept going. But now we're going the other way.
Wait, wouldn't it be 2 minus 3?
I don't have any minuses. Everything's plus. I just flipped which one's bigger. If
I like this.
A is less than B, so if the number by itself is smaller, you get an inner loop. If the number by itself is bigger, you get what you just drew, which is not an inner loop.
It looks more like a cardioid.
It does look like a cardioid, but it's not an exact cardioid because it doesn't go back to. So let's make up one. Let's go 5 plus 3 sine.
What if they're equal?
Yeah, we don't want to get there. Let's don't.
5 plus 3 sine.
If they're equal, we saw that. If they're equal, it's a cardioid.
It's like a cardioid.
This one we saw.
I think it's going to keep looking like a cardioid.
5 plus 3 sine. Sine goes on the y-axis. 5 plus 3 means we're going to go up to 8. And 5 minus 3 is 2, meaning we should go down 2 below. Is it working out like you think?
It's 5 plus 3 sine theta.
Yes.
Wait, so what's the
But it
difference in
still looks weird.
those two? Because they're called the same.
Yeah, I think this I would ignore that. I think that it's a poor job.
Plus
So just look the right one.
Yes.
Sine theta.
This one shouldn't have an interlude. I don't. It's just
So
a regular.
this one should
Lima
be
song.
what we're doing.
Yes. That third version is what we're drawing right now. It's not the interlude. Okay. Everybody good with that? You get some idea.
Jack's just doing random shapes.
Yeah, thanks.
No, I'm still doing your shape too, but there's.
He's keeping all of
All right. This one is not super important for AP pre-cal.
Can we learn it? It looks cool.
Well, they're showing you right here.
That one looks like
If you can make it be r squared equals a squared times sine of 2 theta.
How do we do that?
Well, you can't on your calculator. You'd have to use Desmos. So that's why I'm telling you this one's not that big a deal in AP pre-cal because they're going to let you be able to do it on your calculator. All right? So I'm just going to sideline that one.
Rose curve even.
Let me scan.
Now these are important. The rose curves.
Ooh.
I like those.
So this is, let's learn about these.
Amazing.
So let's start with an even number of petals. So let's type in,
Finish.
let's type in 5
Cosine
cosine.
92.
It's got to be even. Let's don't put 92. Let's put 4 theta. 5 cosine 4 theta.
Already tried that.
Looks like I'm doing it. I think spit that
5
out quick.
cosine 4 theta.
He started.
Okay. What do we notice about this? It's a flower looking thing, right? Like, so called a rose curve.
It's an octagon.
It goes.
It has 8 petals and there's a petal in the middle of the x-axis. You guys see this? In the middle of the x-axis, we got a petal. So let's go back. Keep it as 5, but let's go times cosine of 5 theta
5
instead of 4 theta. 5 cosine 5 theta. So all that I'm changing is from 4 to 5. Do we still have a petal on the x-axis?
Yes.
I mean, that didn't change. But how many petals are there now?
5.
So I put in 5 for n, and I have 5 petals.
It's because it's an odd number.
That's correct. Let's keep going. Go to 6 theta. And it's a 6 theta.
There's
12 petals, because it's an even number for n, and it still goes through the x-axis, right? One in the center. Everybody's okay with that? Now, I want you to go back. Let's change it to sine of 4 theta. So 5 sine of 4 theta. So when you see 4 theta, how many petals do we expect? 8. What's different between sine and cosine?
There's none on the X or
It's
Y.
not on the x-axis. Don't say that about the y, but it's not starting on the x-axis. Why is this? Think about it. Cosine, when I start my rotation, cosine starts at 1. Sine starts at 0. So as I'm going and start drawing these petals, cosine already starts out here, where sine does not. Sine starts in the middle every time. So cosine has a petal on the x-axis every time. Sine does not. And then, does everybody understand the number of petals? If n is an even number, it has double that number of petals. If n is odd, it has that number of petals.
I created an explosion.
Nice. Everybody good with this? I'm not going to do 9. This is just showing you how that works. All right? We're plotting points. You're picking thetas. You guys told me you had to do that on the homeworks. So I'm just going to let you learn that there and keep